Today we're going to talk about graphing lines from equations. So if I give you this equation, y equals 2x plus 4. This equation is a linear equation. What does it mean for an equation to be linear? Well, if you look at the first four letters of linear, you see line. And that's exactly what it means. A linear equation graphs to make a line. All lines are straight. All lines have arrows on the end because they go on forever. They don't curve. They don't change direction. And they will fit, hopefully, on our graph here. So if we look at this equation, we have y equals 2x plus 4. We really have four pieces of this equation. So instead of writing it like that, I'm going to write it like this. Y equals mx plus b. Now you can see the four pieces of the equation. Let's start with the x and the y. The x and the y are variables that really just stay as x and y. You'll look that this equation has an x and a y. It just stays as an x and as a y. The x is what we call an independent variable. An independent variable can be whatever you want it to be. Independent means, no control. It has its own power, right? So if it's an independent variable, it can be whatever number we want it to be. On the other side of the equation, we have y, which is a dependent variable. Y is a dependent variable. That means that the value of y is entirely relying on another variable or another set of information. And if you look, this equation says y equals. So that means to figure out what y is, you need to do all the stuff on the other side so you know what y is equal to. So hopefully that makes sense to you. So when we write equations, the x and the y stay as x and y. Now these other two pieces of information, the 2 and the 4, are represented by the letter M and the letter B. And you're going to argue with me that these letters make no sense, and I completely agree with you. The M represents the slope of the line, and the B represents the y-intercept of the line. Notice how slope does not have an M in it, and y-intercept does not have a B in it. I don't know where the letters came from, but we're just going to go with it. All right, let's start with y-intercept. The word y-intercept talks about where does this line run into the y-axis. Intercept means run into or get in the way of, right? When a football player throws an interception, someone else got in the way of the pass and took it from him, right? So the y-intercept in this equation is 4. So if I want to start to graph this, I'm going to go to the graph here and I'm going to put a point on 4. That's all that this 4 tells us. We have a point on the y-axis on 4. This number will just tell us where to put a point, and then we're done with it. We don't need it anymore. The slope is a little more complicated, not much. The slope tells us, I think, a little more information. Having a slope of 2, the slope is the steepness rating of the line we're about to make. All right, think about it. The only really exciting thing we can change about this line is how steep of a line it's going to be. All right. The other thing that number tells us is the direction of the line. Think about it. If I need to draw a line through that 4, it might go like this, it might go like this, like this, like this, like this, like this. There's a bunch of possibilities here, right? So this 2 is going to tell us the direction and the steepness. And it does that with the value and its sign. Okay, so let's start with this. The sign of the slope is positive, right? 2 is positive. That means that this line is going to have a positive slope. Lines with a positive slope always go in this direction. From left to right, they are going uphill. If this number were negative, any negative number at all, then it would have a negative slope and it would go in this direction, downhill from left to right. If this number were a 0, 0x, then that means that this line would have no slope. A line with no slope is horizontal. Think about it. If your floor in your house has no slope, then it's just a horizontal line, has no steepness. And if this number here is the biggest number it could possibly be, it's an infinite number. We'll get to this later, but it has an infinite slope, and it will go up and down. It will be a completely vertical line. But we'll get back to that on another day. So this number is 2, and it's positive. So that means our graph, when we're done, is going to go in that direction. So it might be like this, it might be like this, it might be like this, but we know it's going to go from left to right, it's going to go uphill. The other thing that number tells us is its steepness. So a slope of 2 tells us that it's going to be kind of steep. We can't just, like look at it and kind of gauge it just by how we feel. There's actually a formula to find slope. The formula to find slope is change in y over change in x. You might see this abbreviated like this because this triangle is actually a Greek letter delta, and delta in math means change. So the slope of this equation is 2, and what that means is that it has a steepness rating, a change in 2. But the problem with that is this formula is a fraction, and this number is not a fraction. We can easily fix that by changing this to be a fraction. All numbers that aren't a fraction are secretly over 1. So that means that this line has a steepness of 2 over 1. That means I need to change y by 2 and x by 1 for every point I need to make. To make a line, we only need 2 points, right? Because once we have 2 points, it's never going to change after that. It's never going to turn or twist or anything like that. So we have 1 point. We only need 1 more point. So to find our next point, we're going to use this. Change in y is 2, and change in x is 1. If we're changing y, the y value, the y coordinates go up and down, right? So if we're changing y by 2, then we're going to go up by 2. And if we're changing the x by 1, that means we're going to change left or right by 1. So we're going to go up 2 and over 1. That's it. We have our 2 points. Our line is technically done. We would just use a ruler and connect those 2 points. But I can make as many points as I want. I'm going to make some more points. To get my next point, I would go up 2 and to the right 1. Now I'm out of room, so I can't go up 2 and over 1 anymore, but I can go down 2 and to the left 1, down 2, to the left 1, down 2, to the left 1. I can make as many points as I want. When I connect this with a ruler, which I don't have in front of me, that was a pretty good line without a ruler. When I connect this with a ruler, not only are all those points part of this line, but all the space in between, all the places we drew a line are also parts of this line. So this random point in the middle of nowhere, it's on the line, so it's also a part of this line. That means it's a part of this equation. It's a solution to this equation, and we'll get to that another day. All right, the only other thing you want to do when you make a line is to label it with your equation and make sure it has arrows on the end. You also want to make sure it fills a lot of the graph, right? If I would have stopped there, that would be a very dinky graph. I want it to fill as much of the graph as possible. Okay, so let's do another one. We can do it right here. This information here will be helpful to us. So if we want to graph y equals 1/3 x minus 5, this equation's set up just like the other one. We have y all by itself, just like this one. We have the x still remaining x. And most importantly, we have a value here for our y-intercept, -5. And we have our slope of 1/3. That means my y needs to change by 1, and our x needs to change by 3. So I need to go up and down 1, and I need to go left and right 3. So I'm going to go here, and I'm going to go up 1 and over 3. Up 1 and over 3. Up 1 and over 3. If I want to go that way, I'm going to go down 1 and over 3, down 1, and over 3, down 1, and over 3. And we have our line. Man, I'm 2 for 2 on making really good lines without a ruler. You'll notice this line is less steep than the other one. That's because the slope is a lower number. 1/3 is less than 2, so the line is less steep, right? The -5, instead of being +4, the -5, remember all that did is it slid the y-intercept to be down lower. So you might be saying to yourself, why, when I'm making these lines, am I choosing to go up and to the right or down and to the left? How do I know that that's the direction I need to go? Well, look at this little sketch I did over here. I know that both of these are positive, so I know that my line needs to go in this direction from left to right. It needs to go uphill. So when I'm choosing which directions to go, I have to go up or down first, and then I have to go left or right first. But I want to make sure when I'm all done that my line is traveling in the correct direction. Both of these from left to right are going uphill. So I'm making sure when I go up and to the left, yeah, that's going in the correct direction because positive lines go left, from left to right, they go uphill, right? So if we do another one down here, y equals -3x plus 2. This one has a negative slope, so we know it's going to look like this, right? It's going to go downhill. That's the only thing that changes about this. The y-intercept is still 2. Just like these two, you just put a point right there and say, that's my y-intercept. This one, like the first one, does not actually have a fraction for its slope, but that's okay. We're just going to put it over 1. So now I need to know that my up and down is 3 and my left and right is 1. Another way to look at this when I'm determining where to go, this is a -3, right? So when I'm choosing up or down, I should choose down because negative direction for up or down is down, right? If it was positive, I should go up, but it's negative, so I should go down, right? If you go down, that's negative. So I'm going to go down 3. I'm going to temporarily stop there. And I need to go left or right 1. This is a positive 1, so I should go to the right 1. So there's my second point. Down 3, left or right 1, down 3, right 1. Now if I want to go the other way, instead of making this negative, I'm going to make this negative. I'm going to make that positive. This number is -3. So as long as one of the numbers here is a negative direction, then I'm fine, right? So if I go up 3, 1, 2, 3, I just need to make sure I go left 1. One of the directions I travel to make this these points needs to be a negative direction, right? So going up is a positive direction, so I'm going to go left so that I have my one negative direction in there. If both the directions I travel were negative, they would cancel out and it would actually be a positive direction. There we go. Another beautiful line by Mr. Eschborn. There we go. There is our graph for that one. So good luck on the assignment that I've posted here on Delta Math. If you have any questions, you can shoot me an email. Delta Math also has some helpful videos. Feel free to use them. And I hope you enjoyed this. I hope this was not too bad. So thank you. Have a good day.